June 15, 1943. Liverpool Docks, England. Rain poured down in sheets as Lieutenant Colonel Robert Williams of the U.S. Army Corps of Engineers supervised the unloading of yet another shipment of Quonset huts, America's pride in prefabricated military housing. At 7,000 pounds each and requiring 8 men to assemble, Williams was certain these superior structures would outperform anything the British had to offer. Little did he know that his counterpart across the harbor, Major Geoffrey Thompson of the Royal Engineers, was erecting 6 Nissen huts with half the manpower in the same amount of time it would take Williams' team to build just 2 Quonsets. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the untold story of how American industrial might sometimes met its match in British efficiency, forever changing how military engineers would approach rapid deployment housing. The Anglo-American alliance during World War II represented perhaps the most powerful military partnership in history, combining American industrial capacity with British experience and engineering prowess. Yet beneath the grand strategies and shared victories lay countless small competitions between allies, professional rivalries that would ultimately strengthen both nations' war efforts. Few of these friendly contests better illustrated the different approaches to wartime problem-solving than the quiet battle between 2 seemingly simple structures, Britain's Nissen hut and America's Quonset hut. "Another shipment wasted," muttered Technical Sergeant Frank Miller as he struggled through the mud with his clipboard, tallying the latest Quonset delivery. "Sir, we've now got parts for 26 more huts, but we're still waiting on the specialized crew from the 111th Construction Battalion to put them together." Colonel Williams nodded grimly, rain dripping from his helmet. "I know, Miller. Admiral King himself approved these shipments. We'll make it work." Williams had been in England for 3 months overseeing the massive buildup of American forces before the planned invasion of Europe. His primary responsibility was ensuring proper housing for the influx of American troops, and the Quonset hut, named after Quonset Point, Rhode Island, where it was first manufactured, had been selected as America's solution. "The British seemed to manage just fine with their corrugated shacks," Miller observed, gesturing toward the eastern side of the base where Royal Engineers were rapidly erecting their Nissen huts. "Those are stopgap measures, Sergeant. Our Quonsets are properly engineered structures," Williams replied with perhaps more conviction than he felt. "They have proper wooden floors, insulation, and electrical wiring built right in. Quality takes time." Across the sprawling base, Major Geoffrey Thompson of the Royal Engineers was addressing his own team. At 46, Thompson was older than most officers of his rank, having served in the First World War where he had first encountered the original Nissen hut design. "Right, lads, 6 more to complete before nightfall," Thompson instructed his crew of 12 men. "Captain Norris reports another regiment arriving tomorrow, and they'll need immediate billeting." Corporal James Davies, a former Welsh coal miner turned combat engineer, gestured toward the American sector. "Seems our cousins across the pond are still struggling with those fancy Quonsets, sir. Wouldn't mind having a few of their extra hands." Thompson smiled thinly. "Perhaps, but I'd rather have men who know what they're doing. Our Nissen design has been refined since 1916. Sometimes the simplest solution is the most elegant." He paused, watching the American crews with their heavy equipment. "Besides, those Quonsets may look impressive when finished, but they're taking up valuable shipping space that could be used for tanks or ammunition." The story of these competing designs began decades earlier. In 1916, during the First World War, Major Peter Norman Nissen of the Royal Engineers developed a prefabricated, semicircular hut made of corrugated steel. The original Nissen hut could be assembled by 6 men in just 4 hours. It required no special skills to erect and used minimal materials, just 4,000 pounds of steel and a small amount of timber, crucial considerations during wartime shortages. By the end of World War I, over 100,000 Nissen huts had been produced. When America entered World War II, the U.S. Navy needed a similar portable structure but opted to redesign rather than simply adopt the British Nissen. In 1941, a team at Quonset Point Naval Air Station in Rhode Island developed their version, the Quonset hut. While clearly inspired by Nissen's design, The American version incorporated several changes that its designers considered improvements: wooden floors, insulation, and finished interior walls. The first Quonset huts weighed approximately 7,000 pounds compared to the Nissen's 4,000. They required specialized assembly teams and took significantly longer to erect, typically 8 to 10 men working for 8 to 10 hours. American manufacturing might produced over 170,000 Quonset huts during the war, but the question remained: was the more complex design actually more effective in wartime conditions? The problem isn't the design, it's the shipping, explained Commander Richard Phillips of the U.S. Navy Bureau of Yards and Docks during a coordination meeting with British counterparts in London. Each Quonset kit takes up 670 cubic feet of shipping space. We're losing valuable transport capacity that could carry other supplies. Air Commodore William Barrett of the RAF listened politely before responding. Our Nissen requires just 400 cubic feet per unit. In fact, we've calculated that for every 3 Quonset huts you transport across the Atlantic, we could ship 5 Nissens in the same space, while also requiring fewer specialized personnel for assembly. Phillips bristled slightly. Our men deserve proper accommodations. The Quonset provides superior insulation and comfort. Comfort is relative in wartime, Commander, Barrett replied. Our lads manage quite well, and they're deployed much faster. Time is often the most precious resource of all. Back at the Liverpool base, this difference in philosophy was playing out in real time. Sergeant Miller had finally assembled his specialized construction team and was overseeing the erection of the first Quonset hut. Careful with that section, Miller called out as 8 men struggled to position a curved steel section. Make sure the J-bolts are properly aligned before securing. The process was methodical but slow. First, the wooden floor had to be perfectly leveled and assembled. Then the steel ribs were bolted to the floor one by one, requiring precise alignment. Next came the exterior skin of corrugated steel, followed by the interior masonite hardboard walls and insulation. Finally, windows, doors, and electrical fixtures needed installation. After 8 hours of continuous work, they had completed just 1 hut. Meanwhile, Major Thompson's Royal Engineers had completed 5 Nissen huts in the same time frame. Their process was strikingly different, focused on speed and simplicity. A Nissen hut began with a simple brick foundation laid directly on graded earth. The iconic semicircular steel ribs were quickly bolted together and erected. Then the corrugated steel skin was attached with minimal fasteners. The entire structure could be assembled using just hammers, wrenches, and manpower. We'll add wooden floors later if time permits, Thompson explained to a curious American lieutenant who had wandered over to observe. The priority is getting a roof over our men's heads. Refinements come after the essentials. The lieutenant, James Westbrook from Minnesota, watched with undisguised admiration. I've got to say, Major, your team works together like a well-oiled machine. Thompson nodded appreciatively. Experience is a great teacher, Lieutenant. We've been building these since before I had gray hair. He paused, then added diplomatically, though I must say, your Quonsets look quite comfortable once completed. When completed is the operative phrase, Westbrook admitted. At our current rate, your men will be sleeping under cover 3 days before ours. The difference is extended beyond assembly time. Captain Eleanor Chambers, a logistics officer with the Women's Army Corps, had been tasked with calculating the efficiency of various structures across the European theater. Her findings were revealing. The numbers don't lie. Colonel, she explained to Williams during a briefing. For every 100 Quonset huts we ship from the States, we're using enough cargo space to transport 14 Sherman tanks. The British can send 167 Nissen huts in the same space. Williams frowned at the charts spread before him. And the manpower requirements? Equally disproportionate, sir. We're using specialized construction battalions that could be building airfields or repairing bridges. The British use combat engineers who receive just 2 days of training on Nissen assembly, then return to their primary duties. Williams leaned back in his chair, considering the implications. But surely our product is superior? The insulation alone makes a significant difference in winter conditions. Yes and no, sir, Chambers replied carefully. Our surveys show that while Quonsets are initially more comfortable, they're actually less adaptable to extreme conditions. The Nissen's simplicity allows for quick modifications in the field, extra insulation in Norway, improved ventilation in North Africa. Our Quonsets are essentially the same whether in Iceland or Italy. As winter approached in late 1943, these differences became increasingly apparent. During a particularly fierce November gale, 3 partially completed Quonset huts on the Liverpool base were severely damaged when high winds caught the large steel sections before they could be fully secured. Meanwhile, the British engineers simply halted construction of their Nissens, having learned from experience that certain stages were vulnerable to high winds. "It's not just about the design," explained Corporal Davies to a group of American engineers over warm tea in the mess hall. "It's about understanding the limitations. We never try to attach the corrugated sheets in high winds, too dangerous, and waste materials when they get bent. Instead, we use bad weather days for prefabricating interior components or improving existing huts." Staff Sergeant Paul Rodriguez from New Mexico nodded in understanding. "We're learning similar lessons the hard way. Our manufacturing approach assumes ideal conditions and specialized equipment, but war rarely provides either." The conversation illustrated a deeper philosophical difference between the Allies. American industrial doctrine emphasized standardization, specialized roles, and manufacturing precision. British approaches, shaped by years of material shortages and combat experience, prioritized adaptability, simplicity, and field modifications. This difference was quantified in a February 1944 report by the Allied Combined Resources Committee, which analyzed various equipment efficiencies across the war effort. Lieutenant Commander Howard Rickover, who would later become famous for developing America's nuclear navy, contributed a particularly insightful analysis. The British Nissen and American Quonset represent 2 approaches to the same problem. The American solution optimizes for comfort and completeness, using 76% more materials and 114% more labor hours to achieve a 22% improvement in insulation value and interior finish. The British solution optimizes for speed of deployment and material conservation, accepting reduced comfort as a necessary wartime compromise. In the current strategic context, where shipping capacity represents our most critical constraint, the committee recommends a gradual shift toward the Nissen philosophy while incorporating selective Quonset improvements. This analysis reflected a growing recognition within American military circles that sometimes good enough now outperformed perfect later in wartime conditions. It was a lesson being learned across many facets of the Allied war effort. By early 1944, as preparations for the Normandy invasion intensified, both Colonel Williams and Major Thompson found themselves assigned to the massive buildup in southern England. Their teams were now working side by side, establishing camps that would house the invasion forces. "I hear congratulations are in order, Major," Williams said one evening as both officers reviewed construction schedules. "Word is you've been selected to help plan the follow-on facilities after we establish beachheads." Thompson nodded modestly. "Just doing my part. I understand you'll be joining the effort as well." "Indeed. Seems our superiors have decided our competing approaches might actually complement each other," Williams replied with a small smile. "Though I admit, we've been incorporating more of your methods lately than I expected." Thompson raised an eyebrow. "Oh, our latest Quonset variation is 30% lighter, uses fewer specialized fasteners, and can be erected by 6 men instead of 8, Williams explained. "We're calling it the Quonset redesign, though some of the men have started calling it the Nissenity behind closed doors." Both men laughed, the sound of shared professional respect replacing the earlier competitive tension. The evolution of these structures reflected a broader pattern of Anglo-American cooperation, initial competition giving way to mutual learning and eventual synthesis of best practices. By mid-1944, American engineers were producing a streamlined Quonset that incorporated many Nissen efficiencies, while British designs had adopted some of the Quonset's interior improvements. On June 11, 1944, 5 days after the initial D-Day landings, both Williams and Thompson found themselves on Omaha Beach overseeing the rapid construction of facilities for the growing Allied presence. The scene was one of controlled chaos as men and materials poured ashore. We need to house 1,200 men by nightfall. General Omar Bradley's aide informed the assembled engineering officers. And we need the medical facilities operational within 6 hours. Williams and Thompson exchanged glances. This was exactly the scenario that had fueled their professional debate for the past year, when rapid deployment mattered most. We'll use a mixed approach, Williams decided. Nissen huts for immediate medical and communications facilities, Quonsets for longer-term headquarters and supply storage. Thompson nodded in agreement. My teams can have the first 6 Nissens up within 3 hours. We'll prioritize the field hospital. By sunset, the combined engineering teams had established a functioning base camp with 24 Nissen huts and 8 Quonsets. The Nissens housed the essential immediate operations, while the more robust Quonsets were positioned to serve as longer-term facilities. It was a pragmatic compromise that played to each design's strengths. As the two officers surveyed their accomplishment from a bluff overlooking the beach, Thompson offered Williams his canteen of tea. Not quite the competition we envisioned back in Liverpool, is it? Williams took a grateful sip. No, it isn't. Turns out when there's an actual objective rather than national pride at stake, the best approach becomes clearer. He gestured toward the growing installation below. Your Nissens got our wounded under cover 3 hours sooner. Our Quonsets will keep the command staff dry during the weeks of planning ahead. Both have their place. Thompson retrieved his canteen with a nod. The perfect is the enemy of the good, especially in wartime. Sometimes I think we engineers forget that our creations are means to an end, not ends in themselves. As the Normandy campaign progressed, this pragmatic approach continued to evolve. By August 1944, the U.S. Army had formally adopted a new theater of operations, building strategy that explicitly combined British rapid deployment techniques with American standardization. Captain Eleanor Chambers, now promoted and assigned to General Eisenhower's logistics staff, documented this evolution in her post-action report. The hybrid British-American approach to deployable structures yielded a 37% increase in housing capacity using the same shipping volume compared to our 1943 methods. British Nissen huts provided immediate shelter within hours of arriving at new locations, while American Quonsets supplied more durable facilities for sensitive equipment and winter operations. This complementary system has been recommended as standard practice for the anticipated Pacific Theater operations. The story of these competing designs had significant implications beyond the war. Peter Nissen's original 1916 patent had expired just before World War II began, allowing his design to be freely adapted. After the war, surplus Nissen and Quonset huts found new life as affordable housing during the post-war shortage, agricultural buildings, and even churches and schools. Their distinctive curved profiles became an iconic part of post-war landscapes from Britain to the Philippines. More importantly, the lesson of their development, balancing immediate practicality against ideal specifications, influenced military procurement for decades to come. When Colonel Williams returned to the Pentagon in late 1945 to help shape America's peacetime military engineering doctrine, he brought with him a new perspective shaped by his European experience. The perfect solution deployed too late is no solution at all, he wrote in his influential 1947 manual on expeditionary logistics. Our objective must be the optimal balance between quality and timeliness, always remembering that in conflict, initiative often outweighs perfection. For his part, Major Thompson, by then promoted to lieutenant colonel, helped establish Britain's post-war civil defense infrastructure, incorporating lessons from both the Nissen and Quonset programs. The rapid deployment principles he championed became a cornerstone of NATO's early response strategy during the Cold War. The human dimension of this story extended to the men who actually lived in these structures. Private First Class Michael Garrity from Boston spent 18 months in Quonset huts across England, France, and finally Germany. His letters home captured the ordinary soldier's perspective. Our new quarters are these half-cylinder huts that look like tin cans cut in half, he wrote to his mother in July 1944. Not exactly the Ritz, but after weeks in foxholes, they feel like luxury. The British lads next door have similar huts they call Nissens. There's one up faster, but leak more in the rain. Ours took forever to build, but stay warmer at night. We trade, They come over when it's cold. We go to them when we want to get set up quickly after moving. Funny how even our buildings reflect our national characters. By war's end, over 170,000 Quonset huts and more than 100,000 Nissen huts had been deployed across every theater of the war. Their combined impact on the Allied logistical effort was immeasurable, providing quick shelter for millions of personnel and countless tons of supplies and equipment. In the decades following the war, military historians began to recognize this Battle of the Huts as emblematic of the special Anglo-American relationship, initial competition giving way to mutual respect and eventual synthesis. The final product was stronger than either nation could have produced alone. At a 1970 reunion of wartime engineers in Washington, D.C., now retired Major General Robert Williams and Brigadier Jeffrey Thompson met again. Their wartime debate long since evolved into friendship. "I still maintain our Quonsets were superior structures," Williams said with a wink as they shared drinks at the Army-Navy Club. "And I still maintain we could build 3 Nissens in the time it took you to build 1 Quonset," Thompson replied with equal good humor. "Perhaps we were both right," Williams conceded, raising his glass. "And perhaps that's why we won the war." The rivalry between these two simple structures embodied a larger truth about the Allied war effort. Britain, with its imperial experience and early exposure to the realities of modern warfare, contributed operational wisdom and practical efficiency. America, with its vast industrial capacity and technical innovation, provided scale and resources. Neither approach alone would have been sufficient, but together they proved unstoppable. Today, both Nissen and Quonset huts can still be found around the world, weathered monuments to wartime ingenuity. A few serve as museums, while others continue their practical service as storage buildings or workshops. Their distinctive curved silhouettes, whether on an English countryside or a Pacific island, stand as quiet reminders of how seemingly minor engineering decisions can have major strategic impacts. In 2002, when American forces rapidly deployed to Afghanistan, they used modern equivalents of both designs: quick assembly structures for immediate operations and more substantial prefabricated buildings for long-term bases. The lessons learned from those rainy days in 1943 England continued to shape military thinking into the 21st century. The humble Nissen and Quonset huts represent something more profound than mere military housing. They embody the pragmatic innovation that characterizes effective wartime problem-solving. In the high-stakes environment of global conflict, theoretical perfection often must yield to practical sufficiency. The British understood this from bitter experience. The Americans learned it through partnership. In war, Thompson once observed, "The question is rarely what would be ideal, but rather what can be accomplished with available resources in the necessary time frame." This principle, demonstrated in the competition between curved steel shelters, ultimately contributed to history's greatest alliance and the preservation of freedom across the world. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.